f of x is equal to 2x cubed plus 3x squared minus 12x. I go take the derivative of it. I get 6x squared plus 6x minus 12. I find extremas where this is undefined. Endpoints. Careful. We have endpoints. That's a surprise. And where the derivative is equal to what? 0. So I'm going to set the derivative equal to 0. So you divided out the 6, it sounds like, which is a good move. X plus 2, x minus 1, which means I have critical points at x equals negative 2 and positive 1. Now, I now know increasing and decreasing behavior are going to happen between negative infinity and negative 2, and it cannot change between the two, because the only extrema is going to be a maximum or minimum, right? That's it. So it's got to be between those two. Between negative 2 and 1, something might be happening. And between 1 and infinity, something else might be happening. All right, let's take a whack at this. So we're going to pick a number between negative infinity and negative 2. You got one? Negative 10. I'm going to plug it into my what? My derivative. Okay? So I'm going to check at my derivative at negative 2 is going to be equal to, you said 10, huh? That's 600 minus 60, which would be 540 minus 12. Good. That's what we're going to be doing, by the way, right? But it's 528. I'm going to make the point of saying it's 520. But you're right. All you have to do is whether it's positive or negative. I don't care what the number is. I just want to know it's positive or negative, right? So it's positive, so it's what? Increasing. Yeah? Now I check between negative 2 and 1. What are we going to check? 0. Good call. I get negative 12, which means it's decreasing between those 2 points. And 1 and infinity, I'm going to check 10. Think you're funny. All right, fine. 10. 600, 660, 648. Which means it's increasing, right? So this function starts down here, goes up to a point at, when I get to negative 2, it gets to a maximum of some sort. Then it starts decreasing until it gets to 1. And then it starts increasing again. Yes, ma'am. You can have situations where it's like doing this and then it keeps going, right? Keeps increasing, yeah, increasing, increasing. You can have a function where it dead ends and then suddenly appears down here, where it's increasing, increasing. I understand these don't have to be continuous. We're backing away from MDT now. Okay, last but not least, what does that make? What is happening at x equals negative 2? What do we call that point? It's an extrema. It's specifically a maximum. When you're increasing before it and decreasing afterwards, that makes this a maximum. We call that the first derivative test for whether or not it's a maximum or minimum, right? If I'm increasing before it, decreasing after, that is the maximum. If I'm decreasing before it, increasing afterwards, what is it? It's the local minimum or relative minimum. Could be an absolute minimum, by the way, too. In this case, it wouldn't be. But does that make sense? When you get the test, AP test, they're going to ask you, find all the local minimums or all the relative minimums. They'll say that. Or they'll say find all the absolute. You have to find those. Okay, you have to do what they say. Don't risk making up your own words, right? They ask you for absolute maximums, you write relative maximums. They're going to take away the points whether you right or wrong. It's kind of weird. Okay? Yeah.
Can you just go over how you found that?
Okay, so we found that our derivative was 0 at negative 2 and 1. Our endpoints, because I didn't give you any, are negative infinity and infinity, right? So I'm going to say from negative infinity until I get to my first critical point, I have to have the same thing, increasing or decreasing. Because that's where my slope is 0 or undefined. That's the only way I can change from a positive number to a negative number or a negative number to a positive number, right? So therefore, the only place it can change is at negative 2 and at 1. Okay? So from negative infinity to negative 2, I must be doing the same thing the whole entire time. From negative 2 to 1, I must be doing the same thing because those are my two critical points. And then from 1 to my other endpoint, I must be doing one thing. I don't know what it is, but it has to be doing one thing. And then I use my derivatives. I put it in there. If I get a positive number, it must be going up. The slope's up positive, so it must be going up. If I get a negative number, that means it's decreasing. I'm going down between those 2 points.
And then if they actually gave you like endpoints, would your critical points always be in between the points?
Right. Your endpoint, this would become your endpoint, and that would become your endpoint, right?
Yeah.
That's the only difference.
Yeah, and then there'll always be a problem where like your critical points will be in that bound.
Always a funny word. I mean, I can give you like f of x equals 2x or something. Then you do the derivative, you get 2, and you're like, well, where's my critical points? There is none. So it's either increase or decreasing the whole entire time if I have a balance. Which makes sense because in the line it has to be, can't turn. Yes, ma'am. 4 are non-calculator, 2 are calculator. And frankly, you're going to hate the calculator ones. Because the calculator ones, as of late, what they're doing is they're just turning them into number fests. Like 66,437.838 times 1.704 plus, you took one last year, sir. Am I right on that? That the calculator part of the test, the free responses, they turn them into number fests. They got a bunch of random numbers that multiply. They're just huge and ugly. It's like the last 2 or 3 years, it's been like all of a sudden they're like, well, so they got a calculator. Let's see if we can find really bad numbers for them to use. Maybe. You should absolutely check it. Let me put it that way. You should absolutely check it. Right. But be aware that they know what your calculator does. And so one year they had a beautiful one, made me giggle. It was on the calculator part of the test, the second part of the test, and they had increasing, decreasing, and it was really rude. They had one that did this. It did this. But it was really slight. Unless you had your window bound, you couldn't see it did that. And so people didn't catch there's a critical point in there. Remember, if you don't list your critical points, you lose points. And they even wrote a 1-page thing in their testing notes saying, students did not realize because they had a calculator, they didn't even check the critical points. Okay. But they took away their points, so. Right. If you have a calculator desk, though, you should absolutely, if I give you something like this, look at a picture. But there's 100 ways I can make it so you don't. Right. Afterwards. Find them, look at them. If it doesn't match, then figure out what's wrong. All right. You have, now, for the next part of instruction, it says, find the critical numbers of any. Find the open intervals in which the function is increasing, decreasing. Then apply the first derivative test to identify all relative extremas. What does that mean? You're going to tell me whether these are maximums or minimums by if it's increasing before and decreasing after, it's going to be a maximum. If it's decreasing before and increasing afterwards, it's a minimum, right? Okay? And that's the first derivative test. Then use your graphing utility to confirm your results. So you're going to throw it in your calculator and look at it and make sure that everything you said is true. Thereby cutting down the amount of time I have to say whether that's true or not, because you're going to look at the calculator and say, oh, I'm right.